Hello and welcome to Database Design Chat number 6. Normalization is dead, right? So we're taking a turn into the technical. We're going more towards the technical topics. We're going to get into the basic tenets of designing a database. And let's be fair, any database. The normalization is dead is a pretty much sarcasm because it's absolutely not. It's very common sense. And we'll get into why. My name is Lewis Davidson. My handle is DRSQL. My link tree, linktr.ee/DRSQL on the web. Just go there. You can get to any of the links, including my YouTube channel if you didn't have to get this off YouTube. And today we're going to talk about the trouble with the normal forms. And really the biggest problem is they sound old and it sounds mathy. And that's not even somewhat the gist that most people should get out of it. Most people should get there's some concepts that make things better if you follow these very simple rules. What's even more bad is when you read the normal forms, it says if you can't be in first normal form, you can't be in second normal form. And that's not even somewhat realistic. There's going to be times when you just don't do it. And then there's this term normal. What is that, right? What is normal? What is the opposite of normal? So it's a normal database is not very normalized in some respects, but every database is normalized in some respects. Even if you're using one of the newer schema-less databases, there's always going to be some field, we'll call them columns because that's what relational databases call them, but there's some sort of field, some sort of bucket to put some text in, put a number in. You're always going to separate those out into more than one thing. And that's generally just the gist of normalization. But understanding all the different relationships and intertwining between those bits of data is what we're trying to do. And then work it out so we don't have any problems with our data. So the good part about normal forms is that they are very much telling you what your database should look like. Even if you can't, if you at least understand the design, how it should be, it's better. I mean, it's very structured. It's going to sound very mathematical. It's going to sound like it has no value for you, but every one of these normal forms, even the ones that are advanced and rarely are spoken of, have some value. And just because this isn't, you can't get it perfect, doesn't mean you can't do it at all. Okay, so let's move on. I want to just go over the different normal forms and just give a high level definition of them just to get us, we're on the same page. And the first is unnormalized. This would be a database that doesn't meet any of the requirements of normalization. And this would just be a text document. If that's the entire database, that is the most unnormalized database. One of the topics that we'll get to further on will be denormalization, and that's where you know what normalized is and you sort of back up. Unnormalized is just completely just chaos. And it has really two terms. If you can't meet the first normal form, which we'll talk about in a second, then you would be considered an unnormalized database, but that's not vaguely reasonable of a definition. Our relational form. So the strict definition of a table is its rows, its columns, they're unordered pairs of data, unordered pair, like the first name column has a value. So there's these pairs of values put together in a row, or what may be called a relation, if you want to get all technical about it and all mathematical about it. And it makes sure that the table meets a certain requirement. And that makes it a table. We have to have a primary key. We have to have some way to differentiate two rows from one another, and they have to be different. We step into first normal form, and it says columns have to have only a single value. And this atomic definition is something we'll talk about later. But atomic just means that you can't break it down any farther than it is and have it mean something to the person who's using it. For example, if you have the first name, if you have a name of Jeff Smith, Jeff and Smith are not atomic. Jeff Smith is not atomic because sometimes you want to know the last name, sometimes you want to know the first name. You put those in their own bits, then they're atomic. If I take a J, E, F, and F and I break those into their individual pieces, the J doesn't mean anything to the user anymore. Okay, so we don't go that far. So atomic means breaking it down to the things that it matters. And no repeating groups is a thing we'll talk about later, but it just means that one row doesn't have a lot of repeated values, a lot of repeated meaning. You don't have payment 1, payment 2, payment 3, things like that. We'll see why. Second normal form means I've got this value that identifies me. I know the person's social security number. Well, I then should also be able to get their first name and last name, right? Their primary first name and last name, their height, their weight, any of those things that are related to a person, and they only have one of them, then that's what a table should be. And then in third normal form, we even go farther and say that every column has to reference the key. It can't reference non-key values. We'll talk a little more later about this concept of functional dependency. But what it means is if I have a value and I change it, if other things have to change because of that value, then I have a functional dependency on them. So there's dependency both ways. And then fourth and fifth normal form are kind of a very generally speaking. You have perfect keys. You have key values, and all the columns in the table that aren't key values are perfect. Well, then inside the key column, you have 5 or 6 columns. Every one of those needs to be dependent upon one another, or you have an issue. And we'll look at that later, probably much later. Probably go with the first up to third normal form to start with before we move back into some of the other kinds of things. And then we'll get back to fourth and fifth normal form. So I'm not going to cover it this way exactly. I'm going to go through each one of the different issues of a poorly normalized database or the database you're normalizing, and kind of show you the reasons why you want to meet that individual criteria. Some of them, like second and third normal form, will have just one kind of issue that you're covering. Some of them, like first normal form and fourth normal form, some of those will have more examples. And along the way, we may even delve into the other normal forms that are out there. Some of them I don't quite understand myself. Some of them I don't understand well enough myself at times. Because really, it matters more that you understand these individual items that you're looking for. This pattern is wrong. I need to make sure that doesn't occur. And that's really what matters. I don't need to know that every single one of the normal forms has been met mathematically, and there's no science sheet. There's nobody going to review your work and see if that's the case. What matters is that you really have the concepts down that you're trying to meet, and you know why they're a problem. All right, until next time. All of this leads up to getting things correct. Proper structure, proper normalization gets things more correct. And this will even be true in your non-relational databases, your Excel spreadsheets. If you start to build a set of Excel spreadsheets and you don't build them in the way that works best with an Excel spreadsheet, you're not getting that. You're not helping yourself. So all of these bits and pieces we'll talk about are really useful to think about with any sort of database whatsoever. Just be careful not to read too much about the normal forms and start to take them as some sort of manifesto that you have to do perfectly and properly every time. I mean, you're going to want to do them perfectly and properly every time, obviously. But because of the nature of reality and time and things, sometimes just knowing the mistakes you're making. For example, say you have this single blob of text and you have a bunch of data in there that you have to manage. If you know what the problems with that are, you can build better software to manage that if that's what you're stuck with. If you don't know what the problems with that are, you're in trouble. Just get over it. Get ready for it. All right. So we're going to go over these things week by week, slowly she turns, step by step, until we get to a stopping point someday. There's lots of topics to talk about, though. Until next time, see you later.